This article is part of the section The Conversation Junior, where specialists respond to the doubts of curious young people between 12 and 16 years of age. If you have questions, do not hesitate to send them to tcesjunior@theconversation.com. Before you start, I invite you to subscribe to our channel and give like if you like this content, so you can be aware of more interesting topics about science and nature. Today, we are going to talk about the geology and distribution of chemical elements on our planet. To understand this, we will make a journey to the origin of the universe and discover how the chemical elements emerged. In the early moments of the universe, simple elements such as hydrogen and helium were created. These light elements were the basis for stars to cook heavier elements, which were then dispersed through the cosmos at the end of their lives. These elements became the bricks of new stars and planets, including our solar system. About 4.6 billion years ago, a dense cloud of gases began to condense, forming the sun and the planets. The chemical elements were distributed differently according to their weight. The lighter ones moved away from the sun, while the heavier ones stayed close to it, forming the rocky planets like the Earth. But the history of the chemical elements on Earth does not end here. When our planet was formed, it was a sphere of magma bombarded by meteorites, which added more elements to its interior. With the cooling of the Earth's surface, the three layers of the Earth were formed: bark, mantle, and nucleus. Gravity caused the denser elements to move inward, while the lighter ones remained in the crust. This creates a paradox. Many abundant elements are at great depths and are not accessible. Fortunately, geological processes, such as volcanoes, help to bring some of these elements to the surface. In addition, chemical elements can be transformed over time. Some unstable isotopes disintegrate, changing their abundance on Earth. One example is carbon-14, which becomes nitrogen-14. Sometimes what we call rare is not really so. Rare earths are more common than gold, but their extraction is complicated. So, their name can be misleading. In short, the geological history of the Earth and natural processes influence the distribution of chemical elements. Geology helps us understand this complex network and ensure our future.